Hi all, welcome to this session on Introduction to MySQL Master Slave Replication. My name is Satish Kumar Sao and I work at Mindfire Solutions as a PHP developer. So today basically we'll be discussing about what is replication in MySQL and some related concepts and as to how to set up a basic master slave replication in MySQL. So let's get started. These are the contents, basically what we'll be discussing in today's session. Like what is replication, concept of master and slave, advantages of replication, methods of replication, how event-based replication works, a demo setup of master-slave replication and MySQL, code config setup from start for allowing app-level support for master-slave setups later, scenarios best for the setup and strategy, conclusion, and references. So, coming down to this basic thing like what is replication? The term replication means copying something, that is, having a copy of something. So, in the context of databases, what replication means is that it enables data from one server to be copied to another server. So you can say that you have a primary server, that is, you can say that it is a master server, and you also have some secondary servers which are not very much responsible for your site, but you have them. And you can say they are the slaves, that is, they are the secondary ones. So what replication enables is that you have another copy of your data, like whatever changes you have in the master, you want them to be replicated or copied over to this another database, okay, another server, which acts as a backup for your master server. And to start with, by default, replication is asynchronous process in MySQL. We'll be discussing this further as we proceed. So, coming to the concept of master and slave, basically, what we would say as master is like which is something which is primarily responsible to our site, like which handles most of the requests, and slaves are which are dependent on this master. So, as you can see in this figure, like clients are requesting to an app, and then we are load balancing the request, so that what this figure does is like we have a master server for MySQL and we have three slave servers. So whatever changes that is happens in the MySQL master server is being replicated over to the three slaves. So whatever data you have in the master, that you also have in the slaves. So in a kind, you are it's like you're distributing the load. Like you can have the master for write purposes, that is, all the writes go to the master, and since those changes are also present in the slave servers, so you can redirect the reads to these slave servers. So thinking of replication in our minds, so what are the advantages of it? So one of the advantages, as we discussed in the previous section, is that you can scale out solutions. That is, let's say you have a server and you have writes happening to that server, but let's say you have increased number of reads. So these reads also happen in that server. So let's say it's increasing the load on your server, that is, you have a very increased number of reads happening. So what you can do is like you can have a one master server where all the writes which your application does happens to it, and you also have, let's say, a slave server. So whatever changes that happen at your master server, that those get replicated over to the slave server, and your application's read requests go to the server, so that the load is balanced across two servers, that is, reads happen on the slaves and the writes happen over the master server. Coming to the second point is data security. It's like you have the master server and you have the same similar data in the slave server. So let's say you want to take some backup or some analysis of data, or you want to change some data. So instead of working on the master server and making the changes in the master server, you make those changes in the slave database, so that even if something goes wrong, you still have the master server and your app still works. The third is analytics. So coming to the analytics phase, sometimes it happens that your application does some processing on data like reports, like fetching and data visualization. So let's say there are many writes happening and you have some very heavy processing going on, so you cannot do the same on the one server. So what the master slave helps you is that writes still happen and it doesn't like throttle your request, and also you are able to make these analytics queries to the read, which is on a separate database server. Coming to the fourth point, which is long distance data distribution. So this is kind of like, let's say you have a master server somewhere in US, and let's say you have some slave servers distributed over the world. Like let's say one you have in Japan, one you have in India, and another you have in Europe. So you have these slave servers, so which helps you in data localization. That is, any requests which happen close to these areas, they request the slaves instead of requesting to the master. So this decreases the data latency, that is the network latency. So these are some of the advantages which you get out of replication. Coming to methods of replication, there's a traditional method based on replicating events from the master's binary log, that is, it is based on a log maintenance mechanism which is copied over to the slaves, and basically the events which are logged into the log is basically row based or statement based. Row based is something like whatever, like row defs, like what changes have happened for a particular row, and statement based is like whether it was an insert query or update query. So uh, it's a mixed type, like it's a combination of row based or statement based. By default in MySQL, it is statement based logging. There's another method which is newer, which is based on the global transaction identifiers, and it is transactional in nature. In this session, we'll be discussing about the binary log mechanism of replicating events. So how event-based replication works. So here you have in the figure two servers, that is the master MySQL server and the slave server. So whatever writes you make, they are done by the master server, and when it does them, it logs these events in a sequential manner in a binary log file. So basically whatever queries it executes, it logs them in a sequential manner, one query after another, in the binary log file. Then you have the slave server. The slave server has two threads that is running. That is, one is the IO thread and another is the SQL thread. So coming to the IO thread, it connects to the master server and it pulls the changes which have not yet been pulled, that is the newer changes in the binary log, and it copies over to another that is binary log file, which is called as relay binary log. So basically, whatever new changes happen in master, it pulls them and copies them over to the relay binary log file. Then you have another thread running, which is SQL thread. What it does is it runs the newer events which have been copied to the relay binary log into the slave database server. So this is how basically the replication works from the master to the slave server. This is asynchronous, that is, the master server does not have to wait that the events have to be like no other further, that is, no further updates or inserts will happen until the events are copied over to the MySQL slave server. So it doesn't have to wait for this process to end, and it continues its inserts and updates. So it's an asynchronous process. You could feel the difference between like a max difference of 100 milliseconds over a few hundred milliseconds difference, but it's quite fast, you won't recognize it. So actually, it's asynchronous, and you also have semi-synchronous, that is semi-synchronous replication, that is whatever writes happen, uh, the next set of writes are not done unless the events have been acknowledged by at least one slave. That is, at least one slave should have those writes copied over to their database server and acknowledge the master that okay, these have been copied over. Then only master does the next set of updates or write events. So that is semi-synchronous, and it also has synchronous, but I think for that one has to use the MySQL cluster. So now we'll be basically doing a demo setup of a master slave replication in MySQL, that is a single MySQL master server connecting to a slave server. So here we'll be using two AWS instances, and we'll be using Ubuntu 14.04 and the default version of MySQL, which comes with a sudo apt get install MySQL server, is 5.5, and we have opened a incoming port 3306 on the master, since the slave server would be requesting the master like MySQL server on this port. So let's get started. So I have these two servers, that is master and slave. So basically I've run these on these two servers, that is they have the updated packages and upgraded packages, and MySQL server has been installed in both of these. So first, starting with the master server, we have to edit the configuration file. So So we head over to the MySQL section. Here we add over these 4 lines. So what we are mentioning here is that we are mentioning the prefix of the file, that is the log file, that is for logging these events it would create a file starting with the name MySQL bin, and every server you have in a master slave setup should have a unique server ID so that these servers identify each other uniquely. So it should be a positive integer number, that is a unique number. So I've given a value of 1 to the server ID, and these two, that is inodb flush log at transaction commit, it's something which you have for consistency and reliability in case of inodb tables where you have transactions happening in your application. And another change which we need to make here is that we need to make this bind address to 0.0.0 value so that it can communicate across network and is not binded to the local environment, and we save it. Then we restart the MySQL server. Now we have to create a slave user which can interact with this master database server for replication. So let's log into the MySQL database. So we'll be creating a username, that is a user with name called Repl, and you can assign a domain like the user REPL can only make requests if it is from a particular domain, but in our case we'll just make it percentile so that it can be from any domain, and we'll give it a password called sleep pass. Then we give the replication grant command, that is the permission to do replication from the master server. Then we flush the privileges so this new changes take effect. So this step which we make here is like flush tables with read lock, is that we are creating a read lock on all the tables so that no new changes are being made to the master server, because here we want a consistent state. So here two cases arises, that is, let's say you have a master server but you have some existing data before you have created the master slave replication. So what you would want to establish is a consistent state, that is, whenever you have a like you have some data, let's say we take the state of you have the master and you have some data in it, so you'd want to, like, whenever you start the replication process, these data you need to move across to the slave server so that it knows like it has to start at a particular binary file possession, so that the data is consistent and nothing is missed in between. So what we are doing here is like we have the master server and we're creating a lock on it so that we get a position of the binary file, and that is the name of the binary file and the latest position in the binary file, so that we can have that state in the slave, so that when the master slave replication is set up and the slave starts pulling data, so it knows that at which point, that is which file and which position inside that file it has to pull events from. So in that way it remains synchronous. So let's say you have no data in your master server yet. So in that case you just need to pull the basic database and the structures which are there, and you just need to pull them over to the slave server, and then after this you just need to start the slave server so that it can pull any new changes. And let's say if your master server has some existing data, then you need to get a backup of all the data using the MySQL dump, and you just need to like copy that dump over to the slave server and make those changes in the slave server, and then you start the slave server at the log file and the latest position in the master server. So that's how the setup goes. So here we'll be having a read lock on all the tables, and then we'll be issuing the command called show master status. So this will show like what is the status of the master. So here you can see that its latest file is MySQL bin and it starts with 001. So this goes on increasing when you have new binary files, and its position is 408 inside that file. Basically we'll be needing this values which we'll be using in the slave server as I have mentioned it before. So I have noted it here. Now let us exit the MySQL shell and we'll get a dump of the database. So let's see. Okay, we have got it. So the next step is to unlock the tables, because we have got the data and we know that at that particular point of data what was the log file and the position. So any new changes whichever happen after we unlock the tables is fine with us, because when we create the slave server we'll be assigning it that log file and that position, so it will pull the new changes from the log file from that position onwards. So now we have unlocked the table. So if application writes to this after we have unlocked, so whatever changes happen, the master server would be writing the events into the binary log and the position would change. So now we'll head over to the slave server where we need to make similar kind of changes. So on the slave server, we'll change the MySQL configuration. We'll head over to the MySQL section. Here we have to give it another unique server ID. So I've assigned it to here, and also you need to change the bind address value to 0.0.0 so that it is able to communicate across the network. So now I restart the MySQL server. Okay, so now it has started. So now we'll connect across to the slave server. So now we'll be issuing the statement that is change master to set up the master slave setup in the slave server. So what we are mentioning here is master host, that is the host name to which that is the host name of the master server to which this slave server has to communicate, and the username of the user which is created for replication access, that is the REPL, and the password of the slave user, that is slave pass in a case. And here, as you would notice, we have the master log file, that is the log file name from which we want to, that is the latest file from which we want to pull the changes, that is the events of the new queries which execute, and we want it from the position called 408 in our case. So I'll copy this over and I'll run it here. So at this point the slave server has not yet started pulling because we have to start the slave process. So at this point what we would want to do is, like, if it's a new database, we would just want to pull the database structures and etc. And if it has some existing data, before we started the master slave replication setup, we'd want to get all those data into the slave server before we start this setup process. So what I'll do is I'll copy over the db dump which we created over in the master server. Okay, so we have it here. Then I'll just get over the data into the slave server. Okay, so let's connect to the MySQL server again. So now what I'll do is I'll start the sleep process so that it will start pulling over new changes from the master server. Okay, so now what I can do is I'll do show slave status. It will show the status of the slave server here. Let me make it more visible. Okay, so here you can see that you have the master host and it tries to connect every 60 seconds for new data. I might be wrong here. Uh, it has copied the data from master log file, that is this, and the read position was, the latest was 408, and these changes have been copied over by the SQL thread which I had mentioned before to the MySQL relay binary log file, and the relay position 253 has been processed by the SQL thread and has been inserted into the slave server. That's what it says. So coming over to the master server, let us log into it. So here we'll see the master status. So it's the same which we had seen previously. So here we'll do a simple experiment, that is, we'll create a table test and we'll see whether let's create a database first. Create database test, but I want to see it across here as soon as possible. So show databases. Okay, we don't have it here yet, so I'm creating a database test and I'd like to see. It was quite fast. So now let's use the database test. So now what I'll do is I'll create a table called persons, and I would similarly want to see the tables created here. So those have not yet been here. So I'll execute it here, and so it's quite fast. Like, let's pulse the events which have been created on the master server, and here I'll create some data. For creating, I'll try to select it on the slave server. Like, it's empty, so I'll insert it here. There's some person names and I'll select it. So you see, it's synchronizing it very fast. So as I mentioned before, on the slave server there are two threads running. One is the IO thread. So if I run show master status, so you see it has not created another binary file yet, but it has changed the possession from 408 previously, I think, to 946. So there have been some new events, and for that, if we do so slave status, so here you can see that for the IO thread, that is master log file, which is this one, it says that it is the last file copied from the master, which is MySQL ben 001, that is this file, and read master log position, that is the binary log for master, is copied over to the relay log file until this position, that is 946. So the slave server has copied the changes over from the master up till the position 946 into the file MySQL relay ben 2. So after this, the SQL thread has two parts here, that is the relay master log file, which is the binary log from master that SQL thread is working on. That is, it is working on the MySQL ben 001 part yet, that is still, and for the current latest, and that is exact master log possession, that is the possession on the master log till which it has executed, that is, it has completed execution by the SQL thread, and it is 946, that is, it has completed whatever was copied over from the master server to the relay bin. It has been executed into the slave server. So these are the four parameters which need to be checked across if you ever need to debug some slave replication issues. So this was the basic setup which I wanted to show you, that is a basic master slave asynchronous replication. Basically, previously I was saying that is connect retry 60, but basically I do not know what it is. Maybe I'll find it and I'll share with you. So coming over to our presentation, the next step is like, okay, this is the setup you have, and so if you are using an application to interact with this kind of database structure setup, so is there any code structure you should use so that it becomes easier? So one question I think it was asked by Amit. He works with me at MySQL Solutions. So there's a basic answer to his question. Like he asked, like, let's say you don't yet have a master slave replication setup, but you're using a single server, and let's say you're planning ahead, like let's say there might be a future need for your application to go over to a master slave replication. And so what are the changes which you could use in your application code so that it becomes easier when your application code moves to a master slave replication setup? So in that case, what would be necessary is like your application should have a database access layer code which should have been properly abstracted. Like here you can see, like you can have something similar to these, like you could have functions, like four types of functions. The first two are basically connect functions. One connects to the write and another is for the read connect. So once you connect through the write, you want to make any write statement using the safe writer statement. So basically what these are, like these are wrappers around connections and execution queries which are redirected to the master and slave server. So in your initial setup, you don't have a master and slave server. So basically all of these four functions would connect across and issue queries to the same server. But let's say once you move across to a master slave, since you know that your application code which does read queries and write queries uses the correct function, that is safe writer connect and safe writer statement, for connecting and writing write queries and update queries. So you know that these functions you just need to make the connect settings to the right database and everything would work, because you know that your application issues all the write commands through these two functions. And similarly it is for the read functions, that is the read query. So if you have such an abstracted modularized code, it would be very easy to move into a master slave replication with little or no change. So the important thing is to have a unified interface for connecting for reads, connecting for writes, doing a read and doing a write. This process may be a little painful and scary at first, but the code will be much easier to maintain going forward. And any issues which you would like to debug into can be, like if you want to benchmark something, or if you want to see what is an error in something, so these two functions give you a very uh, like differentiated view, so you can log queries across these two functions, and you can like localize the errors and benchmarks. And also you can create a user for write only queries to the master server, and also you can use create a user which has only read privileges and use those user credentials for the safe reader connect and safe reader statement light functions, so that you're not able to make any write queries to the slave servers. This is another question which was posed by Amit. That is, what are the scenarios best for this setup or strategy, that is master slave replication? Most of the cases you would not need it. A good designed, optimized, normalized database would not require it normally. MySQL replication is most beneficial for a system that does many frequent reads and infrequent low number of writes. So answering some questions would help you, like whether replication will improve your performance of your system. That is, you should know what is the read write ratio on your system, that is how much percentage of reads are happening and what are the percentage of writes compared to reads in your system, so that if you see that the writes are very less and the reads are happening, let's say 10 to 90%, that is 10% of writes and 90% reads happening, then if you'd want to like make your server more responsive in terms of readable like readness, then you can create some sleeves and issue the reads across to them. And another question is, how much more write load can one server handle if you reduce the reads? So if you reduce the reads, does it improve uh, your writing capability into the master sleeve? If it does, like you should use, like it just gives you like how many sleeves you can, until it just doesn't give you any more performance improvement in terms of writability and readability. And for how many sleeves do you have bandwidth available on your network? So if you have lots of sleeves, it means like you don't have a lot, like you don't have infinite bandwidth, like only you can support some level of slave numbers for. It's actually, you would say that the second and third, like all these three questions, that is the read write ratio and how much, like adding two three slaves and you're still getting a much improved writability on a master server, but at the same time you're also having the bandwidth, that is you added three slaves and it increased the write performance, but at the same time you still have bandwidth available so that your slaves are able to communicate across to the master. So these three questions help you, like whether master slave replication is needed for your application and what is the number of slaves you would want for the master, so that you gain a performance. Some of the examples, like I believe, is like e-commerce sites where people browse more than, like before you go to buy something, you browse many of the things like before coming to a conclusion. So the browsing is more. So here you can see that the reads are more and the writes are very infrequent. Similarly, newspaper sites where only comments and posts are added by the authors and viewers, and it's more kind of a viewing thing. And also online library sites, blogging sites where you have comments by audiences like readers and you have posts by authors. So here browsing happens much in comparison to write. So these are some of the situations which I can think of where you can use a MySQL master setup. Let me think, like did I missed something? Okay, and coming to the conclusion, in most of the case, given good database design for a particular application use case and optimizations and use of indexes, you do not need replication in most of the cases. But if you need to scale out due to a large number of reads in comparison to writes, and you're feeling a load on your server, you should go for it. These are some of the references which I went through, and I hope you have some questions for me, and do not forget them. Like, please post them. I'd like to answer them. Thank you, and I hope you learned something from this session. And thank you for reviewing this. Thanks.